Have you ever wondered what makes artificial intelligence tick? It's not just coding, it's deeply rooted in mathematics. Beneath the complex algorithms that enable machines to mimic human intelligence lies a foundation built on essential mathematical principles. From linear algebra to probability, these areas of math are not merely useful, but crucial. They help machines to process and learn from vast amounts of data, identifying patterns and making decisions. To understand AI, we first need to dive into the specific areas of math that play pivotal roles. At the heart of AI lies linear algebra, a fundamental area that structures data for computers to understand. Imagine you're organizing a library. Each book is a piece of data, and how you arrange these books on shelves is crucial for finding what you need quickly. In the world of artificial intelligence, vectors and matrices act like these shelves, holding and organizing data in a structured manner. Now consider how you might rearrange books to make space for new genres or to highlight popular authors. This is akin to operations in linear algebra, such as matrix multiplication, which are pivotal for data transformations within AI systems. These operations enable AI to adjust and learn from data by changing its arrangement in a way that makes the most sense for the task at hand. For instance, in neural networks, which are akin to the brain of AI, matrix operations help in making decisions and predictions by continuously adjusting and optimizing the connections and weights based on the input data. So, linear algebra helps AI systems understand and transform data efficiently, much like organizing a vast library. How does AI anticipate future events or the likelihood of an occurrence? Welcome to the world of probability and statistics. At the heart of artificial intelligence's predictive power lies the fundamental concept of probability. It's the tool that allows AI systems to